everyone and welcome back. I'm Shanaya here, and in this session I will be talking about binary trees. So before that, let's take a quick review on what nonlinear data structures are and also about the basics of trees for a better understanding. First, let's look at what nonlinear data structures are. Nonlinear data structures are data structures in which data elements do not form a sequence. Instead, the data is organized in a hierarchical or interconnected way, allowing for more complex relationships among the elements. Few examples of nonlinear data structures are trees, graphs, and hash tables. Now let's take a glance at trees. A tree is a hierarchical structure made up of nodes where each node contains a value and links to its children. In a tree, a single element can have multiple next elements, allowing the data structure to branch out in various directions. The tree data structure can be useful in many cases, such as in file systems, organizational models, databases for quick data retrieval, and in routing tables for routing data in network algorithms. Here we have to have a good understanding about the key terms used in trees. The first one is node. A node is the basic unit of a binary tree containing a value or data and pointers to its children, both left and right. The highlighted parts of the tree below shows the nodes of it. Types of nodes are as follows. The root is the first node of a tree. Leaf nodes are the nodes which doesn't have children, and internal nodes, also called as parent nodes, are the nodes with children. The next key term is edge. A connection between two nodes is called an edge. The highlighted parts of the tree below shows the edges of it. Now let's dive into our main topic, binary trees. Binary tree is a tree data structure where each node has at most two children, known as the left child and the right child. There are some keywords related to binary trees as well. The first one is subtree. Any node along with its descendants forms a subtree. The next is balance factor. The balance factor of a node is the difference in heights between the left and right subtrees. Now let's see what are the types of binary trees. The first is balanced binary tree. A balanced binary tree is where the balance factor is not more than 1. In the tree below, if we calculate the balance factor, it would range from 0 to 1, making it a balanced binary tree. The second is full binary tree. A full binary tree is where every node other than the leaves has two children. The third is complete binary tree. A complete binary tree is where all levels except the last are filled, and all nodes are filled from left to right. Here, the last level also can be full. In other words, this is known as a full binary tree but filled from the left. The fourth is perfect binary tree. A perfect binary tree is where all internal nodes have two children and all leaf nodes are at the same level. A perfect binary tree is balanced, full, and complete. Now let's see how we can implement a binary tree. This is a simple Java implementation of a binary tree. This code helps us understand the basics of creating and linking nodes in a binary tree structure. First, we have the tree node class. This class defines the structure of each node in our binary tree.
Now let's see how
The
we
char
can
data
implement a
variable
binary
holds
tree.
the value of the node. We are using a character type to store simple letter data. Tree node left and tree node right are the references to the left and right child nodes of the current node. The constructor initializes the node with the given data and sets the child references, both left and right, to null, indicating that this node doesn't have any children initially. Next, we have the binary tree class. This class includes methods to create new nodes and to set up our binary tree. Create new node is a static method that takes a character as input and returns a new tree node with that character as its data. Now let's move on to the main method where we create and connect the nodes to form our tree. Here we create several nodes labeled R, A, B, C, D, E, F and G using the create new node method. Each of these represents a node in our tree. Then we establish the relationships between these nodes to form the binary tree structure. This sets A as the left child and B as the right child of the root node R. Similarly, we assign children to nodes A and B. For instance, C and D become the left and right children of A respectively. The node F has a left child G. Notice that G is a leaf node because it does not have any children. Finally, we print some values to verify our tree structure. These print statements access and display the data stored in various nodes of the tree, confirming the tree is built correctly. Now let us see the output. So that was a straightforward way to implement and navigate a binary tree using Java. That is all for this session. Thank you for watching and see you in the next video.